there, welcome to 4F, page 102. We're finishing up Unit 4 after this unit, and we'll be ready to review and take the test on Unit 4. So we're going to continue to talk about functions, and we're talking about patterns, and we're talking about a lot of the stuff that we've already done, but we're adding some new vocab and a couple new ideas in 4F. So there is a formal term for a list of numbers that usually follow a pattern, and it's called a sequence. Each member of the sequence is called a term. And when you guys made your list of tables in the past sections to graph, and we looked for the pattern from one Y to the other, that was actually looking at a sequence of numbers, trying to figure out what the pattern was. So if you look at these examples here, they're not giving us an X and a Y. They're giving us just a series of numbers, but they're asking us to describe the pattern, which is what we did in the last unit, and find the next two terms based on the pattern that you come up with. So this is pretty easy to see that you're going to add 4 to get to the next number, starting with the number 3 and going apparently to infinity with this same pattern. So the pattern is, if I asked you to describe it, that's using English words, add 4 to get next term, and then to actually list the two next terms, which it asks us to do, I would get to, of course, 23 and 27. So that one was fairly straightforward. When you look at example B, you might think you're subtracting, because of course obviously you're going down, you're going from 81 to 27 to 9, but you can quickly see that 81 minus whatever it takes to get to 27 is not applicable when you go from 27 to 9, and from 9 certainly to 3. So it's not addition, it's not multiplication, but it is division. So when we look at 81 divided by 3, you get 27. 27 divided by 3, you get 9, and 9 divided by 3, you get 3. 3 divided by 3, you get 1. So we've got to come up with the next two terms. Let's go ahead and write the pattern. So the pattern is divide by 3. However, I like to think of division as multiplication. So if we're dividing by 3, that's the same as multiplying by 1/3. And in looking at the pattern this way, it's going to be easier to get to your two next terms. So we're starting at 1, and we're multiplying by 1/3, which is the same as dividing by 3. So that takes us to 1/3. The next term, multiply 1/3 times another 1/3. That's 1/9. And those are our two next terms. So if you want to stick with the idea of division, 1 divided by 3 is 1/3, and 1/3 divided by 3 is dividing by a fraction, and we invert and multiply. So you're going to end up multiplying whether you do it your way or my way. But I think it's easier to just start out thinking of division by 3 as multiplication by 1/3, and you get to 1/9. Okay, let's move on to this next box. So these sequences right here generally are one of two types of sequences, and there may be a third one. I'm not sure whether they throw in another one or not. But the first kind of sequence that we're going to talk about is arithmetic. And the way I remember this is I see the word arithmetic, and to me arithmetic is basically adding or subtracting. I know multiplying and dividing are in there, but the early arithmetic that you learn is addition and subtraction. So if you have a sequence like we did in A, where the way you get to each term is by adding or subtracting, so adding a positive or subtracting, which would be adding a negative number, the positive, or this is called well, first I got to go back. An arithmetic sequence is the difference between the consecutive terms is constant. So we saw that we had a constant difference from 3 to 7 to 11 to 15 to 19. Okay, so the way we got there was using addition. If you use addition in your sequence, you have an arithmetic sequence. So this uses adding and subtracting to get from term to term. If you look at example B, we didn't use adding and subtracting. It's a sequence, all right, and it's got a pattern, but it's not an arithmetic sequence. It's what we call a geometric sequence, and we'll probably talk about them in the next section. So right now I'm just concentrating on arithmetic sequences. The difference between each term is constant. It never changes, and we get to the next term by adding or subtracting. The positive or negative number that we add or subtract is called the common difference. What is the difference between the two terms? Well, it's positive 4. What is different between 7 and 11? Positive 4. And we usually define that with a variable d. So we're going to look at these examples down here. We're going to talk about whether these sequences are arithmetic. In other words, can you get from each term to the next one by adding or subtracting? And if so, what are you adding or subtracting by? What is the common difference? So when you have fractions, this guy's kind of scary looking in general, but what I want you to do is I want you to get the common denominator. And we've got 2 over 1 and we've got 1 over 1. So the common denominator here is 3. So if I think of 2 as thirds, it would be 6 over 3. And then we've got 5 over 3, and we've got 4 over 3, and we've got 3 over 3, which gets us to this term. So we're taking these whole numbers and we're writing them as fractions, and now it's really easy to see what your pattern is. So we go from 7 thirds to 6 thirds to 5 thirds to 4 thirds to 3 thirds. We are subtracting by 1 third. So yes, this is an arithmetic sequence. Is arithmetic sequence, and our D, our common difference, is negative 1 third, because that's what we're doing from each term to the next. We're adding a negative 1 third, which is the same as subtracting 1 third. If you look at this example, okay, well, how can you get from 2 to 5? Add 3. How do you get from 5 to 10? Add 5. How do you get from 10 to 17? Add 7. On and on. So you're looking, you go, well, this is a fine little pattern. It's nice. But it's not an arithmetic sequence because the change from term to term to term is not constant. It's got to be constant. So this is not arithmetic. It's a sequence, but it's not arithmetic. Now we have a little bit more terminology down here at the bottom. So when you have these sequences, we can talk about which term number are you looking at and what is the value of that term number. These are two different things. So the term number itself, first term, second term, third term, fourth term, fifth term, is n. The value of the term is a of n. What is the function? What is the value of n? And we use a of n to represent that as opposed to which term are you talking about. So we've got an example here. A of 3, it's asking you what is the value, and you might want to write this, what is the value of the third term? So we go to the third term, 1, 2, 3, and the value of a of 3 is 10. What is the value of the fifth term? The fifth term is 1, 2, 3, 4, 5 right here. And the value of the fifth term is 26. So this is pretty straightforward, but the difference between n and a of n is huge, and we're going to work with this a little bit more in the next videos. Thanks for watching.